There is a photograph that should not exist. An astronaut, orbiting Earth 250 miles above your head, pointed a camera downward and filmed a Falcon 9 rocket launching from the planet below. Not a painting, not a simulation, not a composite. Real footage of two human objects in motion at the exact same moment. One leaving Earth, one already gone. The geometry of what you're about to see will break something in your brain about how big the world actually is. Let's establish what we're looking at. The International Space Station orbits at 17,500 miles per hour. That's 4.76 miles every single second. You could drive from New York to Los Angeles in 8 hours on the ISS. From the ground, that orbit traces a circle around Earth every 90 minutes. But here's the thing most people don't understand. The ISS isn't floating in the weightless void of space. It's barely above the atmosphere. It's so close to Earth that if you could somehow jump off and survive the vacuum, you could see individual cities below you. You could see the shadow of a thunderstorm moving across a continent. Now, a Falcon 9 rocket launches from Florida. It goes up, straight up, at maximum velocity, and we're talking about a rocket that can hit 17,000 miles per hour. It takes 8.5 minutes to reach orbit. In those 8.5 minutes, it rises 40 miles. That's the Kármán line. That's the official boundary between Earth's atmosphere and space. But here's where the geometry gets strange. The ISS is already circling Earth at 250 miles up. So when a rocket launches from Florida, moving at nearly the speed of sound, climbing at a 90-degree angle to the horizon, the ISS moving at 4.76 miles per second sideways, can actually catch up to it, can actually see it happen. But there's something else happening in that footage that your brain refuses to process. The horizon. Look at the curvature. It's the limb of Earth, and it's backlit by the sun. That golden line, that thin shell of atmosphere, that's the only thing between vacuum and survival. And in front of it, tiny, bright, leaving a trail of fire, is a rocket. Think about that geometry for a moment. The Falcon 9 is 230 feet tall. From the ISS, 250 miles up. You should not be able to see it. The math doesn't work. A pencil held at arm's length would look bigger. A human hair would look bigger. But the rocket is leaving a plasma trail. It's burning so hot, so bright, that it's visible from a quarter of the way to the moon. When you watch this footage, and you should, because it exists, and it's real, you see something your eyes tell you is impossible. You see Earth's curve. You see a rocket leaving that curve. You see both at the same moment. Your brain is trying to reconcile three pieces of information that contradict your lived experience. You've never seen the curve of Earth except in photographs. You've never been high enough to see a rocket launch from a distance. You've never held two separate moments in the sky at the same time. And yet here it is, documented, filmed by human hands orbiting at 4.76 miles per second. Here's the hidden truth. That rocket is moving toward the ISS. Not directly, not in a collision course, but in the mathematics of orbital mechanics. Every object in Earth orbit is chasing every other object in Earth orbit. They are all falling around the same planet at slightly different speeds. The ISS laps the Falcon 9 every 90 minutes. They are in a race you never knew existed. A race happening right now, over and over, with human beings inside both vehicles, separated by the vacuum of space but connected by the same impossible geometry. For most of human history, we could only imagine this view. We could theorize it. We could calculate it. But we could never see it. We were always on one side of that equation, either on Earth looking up, or briefly in space looking back. We never had the technology to be in two places at once, moving in two directions, documenting the moment one of those directions abandons the other. And now we do. And the footage exists. And it's stranger than we imagined. What this means is this. The world is smaller and larger than you thought simultaneously. The space between Earth and space is so thin that from 250 miles up, the curve of the planet and the flame of a rocket can occupy the same frame. And yet the speed, the scale, the sheer audacity of moving at 17,500 miles per hour while watching something else move at 17,000 miles per hour in a different direction. That's so far beyond human experience that we don't even have a category for it. We can't feel it. We can only see it and know it's real. But here's what stays with me. Here's what the footage doesn't answer. In that moment, the exact moment the astronaut's camera catches the rocket against the twilight horizon, something is being proven that we've never proven before. We are not bound to one world anymore. We have become something that can observe our own escape. We can see ourselves leaving, and we can do it while we're still here. That's not just technology. That's a threshold. That's the moment a species stops being planetary and starts being something else. We've crossed a line and filmed it. The footage exists. But the question of what we become next, the question that should keep you up tonight, nobody has answered that yet.